Welcome back, everyone. We now begin problem solving session with example to be delivered by delivered by our esteemed foreign lecturer, Professor Sukumar Kamla Sadan.
So we have two, ready? Do some fun stuff. We have two part which I'm thinking. One is using, by hand or, calculator or a computer or some. Another one is using, doing on a software, some software. So one thing which is pending from us is to do a power flow example from yesterday. So we will do two. One is a power flow example and one is an optimal power flow example, right? And then after that, you can ask any other examples that you want to solve, and then we can do look solve. So I'm thinking first we will do the power flow example, right? Is that okay? So you want to try this? Yes. So what you can do is you can actually uh, write the impedance matrix. You want to use your computer, you can. How many of you are provisioned in solving something using MATLAB? You're okay, right? Okay. So then what you do is you write it in MATLAB and solve it. You don't have to do it by hand. Okay. How do you write it in MATLAB? Do you know how to write this matrix in MATLAB in a command prompt or something, or you can write it in the form of a script? So I don't know whether, I don't know whether this is, there are several ways of doing the problem solving. So just give you some. How many of you are not proficient in MATLAB? Not proficient in MATLAB, meaning? So, uh, can you, will you be able to partner or join? You are good in MATLAB? No. You are good in MATLAB? He said no. You are good in MATLAB? No. Are you good in MATLAB? No. 5. How many? You just keep saying that's no problem. Okay. How many other are there? Okay. So we may want to probably pair or something, I guess. I mean, need to need to have fun. Otherwise, you will be sitting there and not trading. So just okay. So if you are looking at MATLAB, you get to do in two ways, right? One thing what you can do right in MATLAB is write something in the command window. Do you know how to? What is a command window, right? Command window is this, right? So you can write say um, this impedance here. You can write in the form of a matrix, right? Impedance one, impedance two. That's one way. You can write it in a script, right? Script means in a white space. You can open a white space and write it. Okay. So can you start doing? Everybody comfortable writing, right? Not by hand. Hand is a little take. And whoever has finished this first should raise hands. Should not be doing that. Oh, not that. I thought somebody would be doing by now. Fast typers. Good. Done. Good. Okay. So they should be able to do it. Oh, so anybody has a question on how to do this in MATLAB? You open a square bracket and then you write the first, IE, complex, then you put a semicolon, then you go to the next one. Right? Do you find anything interesting in this matrix? Anything interesting? Can you make use of that interesting things to do it faster? It's actually coming from the physical grid property. It's not a made up. You see, Z bars also like Z13 and Z31 are the same, right? Z23 and Z32 are the same. Can you see that? It sounds like a bunch of numbers, but they have a pattern. And pattern is that these are off diagonal elements. These are the same, right? You see, C12 and C21 are the same. C3, C23 will be same with what? C32. You see that? So why it is like that? Because the transfer impedance between two number or two line, the same impedance, and you cannot change that impedance both ways. Whether you look at this way, whether you look at this way, they are the same. So what does it gives you with respect to your working in MATLAB? You can copy paste. I think he also said that is not comfortable with MATLAB, right? He also said he is not comfortable. So you all the three uncomfortable ones got a computer and then you still not done. I don't want to do the full show and tell. That's the reason I'm forcing them to do it. You're okay, right? And otherwise, what happens is I'll show and tell. I'll give them. They will just click the button, and then because the other way is to give it. If you give it, then it will not do it. Okay, very good. Okay. So since both of them, right? Both of them you're done with both of them. So what that? So you will get an level of understanding here That's the impedance of the two parts, and the impedance of the two parts has got some symmetry. Symmetrical. The matrix is symmetric. What do you mean by symmetry? Symmetry means the opposite of diagonal elements in an answer. And then diagonal elements are the ones which is basically come. I will do something. Can everybody see this? In the back, can you see this? Okay. Who has done the first part on the impedance? You can start on this. So you wrote these two in a script or a command window. Whatever you wrote it, right, in a script or a command window, we can start making a matrix which is V1. And a load. Cross it. Yes. So the elements are complex numbers. First one is impedance of one line. Second one is the second element on the right is the connection between 1 to 2, and the third one is 1 to 3. So this is the impedance of the first line. So this line is actually 3 lines. So it is more like a very good question. So it is more like a so this is I say 1 1 just, and this is a 1 2. This is 1 3. Similar to 1 2 2 2 2. That's for one segment, meaning bus number 1 to 2, and we call it Z12 or something. Then you have another one like us. That's why. That's why. And that is why, that is because the unbalance, right? I mean, 3. So if there is no unbalance, interesting part there. I think, I don't know whether many catch that. Yes, if there is no unbalance, this will go away, that will go away. This one then will become. That's what we do on the transmission network. Done? Oh, still almost. So you are making three metrics, right? One is voltage and two loads. Three. You're doing on a script or a command window? Command. In the command prompt you are typing or you are typing on the script. So are you typing the variables here or on a white space? Here. Okay. Just info. Don't do anything. Just so when you do this, don't use the number, but use the equations you have. So for example, you have a voltage that is 2400, 2400, 2400 in a matrix, which is 24, 0, minus 120. So that voltage you might have given a variable V, I don't know, some variable you have V equal to and a square, matrix. So you say V open bracket 1 comma 1, which is the first element. V open bracket 1 comma 2, second element. V open bracket 1 comma 3, third element, right? So you say, and 127.5 J80 is the S12 1 comma 1, something like that, right? What is the load? So if you look at this S, I don't know whether you've written S load 3. I don't know, whatever the variable you said, S load. Yeah, so S load 3, open bracket 1 comma 1 is 127.5 plus. And V1 is 2400, right? No, you said V2 and V3 is also the same. Did you say that? On V1, okay. So then you go ahead and say V2 equal to V1. Say like that. V2, V underscore 2, or I don't know, whatever variable. V2 equal to V1. Then equal to is assignment. You know that, right? V equal to is not equal to in MATLAB. When you say equal sign, meaning you are assigning the left, right to the left. So V2 equal to V1 and V3 equal to V1. Right. And after we have done V2 and V3. Uh, that's fine. You can write in polar and rectangular. It's up to you. Write it in rectangular. So V2, V3 you already, right? Now you use V3 with type V3 open bracket 1 comma 1. Underscore 1. This is V1. Okay. Yeah, don't use the brackets here, right? Write V1 to underscore 1, please. Good. Do you know how to know whether this is correct or not? So you highlight this from here to here and click F9. Yeah, you click F9. Yeah, F9 will be different. So that's some error in that. So that's how you can take each piece and then check in yours. So that's done. Now you can do V1. You can V3 open bracket 1 comma 1. Did you type? And close bracket. You got something? No, you should have type V3. See what happens on the command wheel. Very good. So now highlight from one scroll up maybe. Highlight from 1 through 9 using your mouse. Highlight 1 through 9. I'll give the same trick to you. Highlight 1 through 9. Line number 1 through 9, highlight. By mouse you can highlight. All the way from top. No, the highlight. It has been okay. F9. F9. Hope you don't delete it. Save it, by the way. You can complete yours. Everything is good. You got everything. Now go say V3. V3. Just the same variable, whatever variable, and see whether you get 3 numbers. Just check whether your code is working. If you say V3, are you getting 2400 angle? Are you getting sir? Yeah. But are you getting type just V3? See whether you get a number. You assigned it, but you should get a number instead. Yeah, type in there to see whether you get V3. Same way with big V. Perfect. So now it's working. Now what you do is that you do this. Uh, now you do this. So spot into matrix. Done. So now what we do is we need two more matrix. This first matrix is V1. You can actually do not worry about angle. You can put in J in a rectangular coordinate. 2500 plus J0. Yeah, you can actually do 2500 plus 2500 cos 120 degree plus 2500 J1. So now what you do is you do V3 comma 1 comma 1. Do you get V3 1 comma 1, right? You get a number, right? So yeah. So V3 1 comma 1 divided by S load 2 1 comma 1. You understand the and make in a form of a matrix. Don't punch out. Fight. I know you're going to self mobile and only don't let him tax. Help him. So I moved out from the impedance matrix. Everybody is okay with impedance, right? You might have completed it. How many of you have not done the impedance? Okay, so impedance. Still fixing internet. Oh, you have done that. Oh, perfect. So this is the impedance is now very nice. So now you can start doing this one. V1 equal to 2500, 2400. That's because you have two dots. See, this one is the first element, which is good. This is the next element. Then space. It should work. Try again. So there's a trick. I don't know if you know this trick. Highlight this. All of up to, no, from Z1. All of until now click F9. F9 is here. You need to also get the command in. Command window is here. Click F9 one more. Okay. When you run it is coming. Try run again. Yes, this is coming. Coming? Okay. Try F. Oh, it's not. This is a problem. So let us see where the problem is. Okay. Yeah, we got it. Go back. So that I think is a docking step. Good. Okay. Good. Good. Can you move this to the now then? Right? Something which is not. Yeah, use bracket instead of parenthesis. Can I use small bracket here? That's correct. So, right. So, the other question I had is similarly this ij. Go here and highlight the first one and control C. Hit here. Right. Ah. So the J didn't like it. So now you do same control C and control V. And then you get rid of the J and say and say I at the end. The other way around. Yeah. And now do the J instead of I. Okay. No, same thing. Yeah. It's good. So instead of J and the friend, you have to get. Yes. Yes. You know how to take care of that, right? Yeah. So do minus and then. How are you doing? How are you doing? Not on the top, at the bottom too. You have to do minus minus. Okay. Well, I have got this impedances, voltages done. Now I want to go for the first class. Now the load. Load is that this is S load 1, S load 2, 3, that one. Oh, okay. S load, S load. Why letting me know this S load? Yes. S load 2 and S load 3 can do any S load. Any variable is fine. Hmm. Hmm. Is V1 done? Can you type in V1 and the command prompt? V1, small V1. Perfect. Okay. So this is all good. Now you do load. And load is S load 2 zeros and this. Then what you do? You can also do the other one now. V2, type in V2 equal to V1. And then V3 is equal to V2. Now you do load.
My value is coming as 0.0900 and your value is coming as 0.32. I will last.
This is, are you doing current calculation, voltage divided by impedance?
Yes.
That one. Instead of 54.42, you are getting
All your values are pretty correct. The last one and
which one?
right one. See.
53.12.
They're approximately equal.
53.12 minus 51.
Minus 33 point something and you also correct.
Yes. Minus 51.
Approximately same, but last value is minus.
Mhm.
If I can find it.
Go back to last. What is it? Something is not correct. S load 3. I load 3. I load 3. S load 3 dot. S load 3 dot.
As V1 is equal to V1 to and V1
S
to
load 3 conjugate. I load 3 is I load 2 conjugate. I load 3 is I 2 3. Yeah, so 0, 75 plus 3, 0 and 0. 0,
last value.
that's good. Okay. Then we have, that is S load 2, right?
Yes.
You have to first find S load 3. I load 3. S load 3.
This load 3, the last value is 13 plus 10 I.
Last value is S load 13 plus zeta. Yes.
13 plus 10 I.
Good.
And when you divide this value,
13 plus 10 I, then you are dividing that with V3. You have to divide with V3.
this is minus 1200 plus 27.28.
V3 is 2400 angle 120. That is correct. 2400 angle 120 is
Minus of 1200 plus 20.
cannot be 2400 cos 120.
So it's minus
Okay.
2078.46.
So you did that. Then can you do one thing? Can you do S load 3? Type it on the command window. S load 3. Open bracket. 1 comma 1. No, not equal. S load 3. Open bracket. 1 comma 1. Close bracket. Divided by V1. Open bracket. 1 comma 1. Enter.
And when we take conjugate, then the answer is 53 point and minus of 30.
Now go.
But the last one,
Go with the arrow up, and now go down here. Here we go 3 1. Enter.
last value is we have issue in last.
It's something else. It's a 3, right? I don't know. Is there anything related to math? Sounds okay for you. S load 3. Can you continue with let me check. I hope that's
We change the load value, then maybe answer this. And when I use 113 plus 105, then answer is close to load value. If I take 113 plus 110, then maybe answer is close to the
I think that could be something in the load value. That could be possible. But I am not sure whether continue with this. Doesn't matter whether the code is right. Put a zero there and see on the end, not one. 130 and 100. 130 and 100. Put a zero then. Mhm. There could not be any typo for one. There could be a typo. 9 plus 67. Is that sign correct?
sign is correct.
Negative 9.
Everything is correct. Only the magnitude.
Magnitude 9 plus 67. Something like that.
I think compared to all other codes, 13 this all are very 137. That's why the value.
One more time.
When comparing with 127.5 and 110, so that's 13 is
Yeah. I understand. But I'm saying that it could not be any typo. Continue with that. So the load is done. I put 3. I load 3. Okay, yeah. Yes, load 3 is one very simple. Yes. And the next is 110. So 5. Yes. Entering the good. Okay. That's now. Now I load 3 is. No. You have to calculate. That's it. Otherwise, there's no purpose. The solution is here. So what you do is you write I node 3 is equal to V3. Oh, by the way, did we say V3? I think we did, right? V3. Yeah, you don't need V3, sir. Yeah. So V3, open bracket. You can actually probably do the whole matrix. I'll show you first without that. V3, open bracket, not equal to. V3, open bracket. 1 comma 1 divided by S load 3, same variable, S load. Right. Actually, the other way. S load 3, open bracket.
then open bracket.
Yeah, not close bracket. No, V3 you have to close it. V3 1 comma 1, close, yeah. Then S load 3, open bracket. No, we don't have to make. S load 3, open bracket. 1 comma 1. Actually, you do this first. S load 3, open bracket, 1 comma 1 divided by, copy that, V1 by, and delete that. See, and enter that. I mean, can you highlight it? Yes, you can. If it is a script, can you highlight the whole thing? Whole thing. You click F9. No, F9 meaning the function. Yeah. Is that correct? So now what you do is there is something which is missing, which is the uh, load. As load 3 you have, right? That as load 3, after you put it, after that square bracket right there, up, no, up, not display, okay, before the semicolon, yeah, multiplied by 1000. So you see KVA there, that is it. And then put a semicolon. And then do this again, you can run it or you have to run it. 53.125 plus 33 points. Yes. Now what you do is, you did this, right? You got to do one more work. You got to go before as load 3 and say conjugate, CONG, J, yeah, open bracket. It's correct, open bracket, then close it. And try again.
F9 or what comes next?
That's possible. And you can continue like that for, so there is another thing which you can do. You can try the enter, copy that whole line one more time. And then instead of 1, 1, delete that bracket and 1, 1, the whole bracket 2. Yeah. And then close the bracket and then put a dot.
There is okay.
And then try it.
Enter.
Yeah, that's it. Try again. So if you do that, then you don't have to do 1. See, 1, 1 is for every element, right? You're not doing 1, 1, you're doing everything together now. So what he was saying, 45.833, that will make this. Yes. I don't like that. 53.1. 45.8 minus 30. 45.8 minus 30. Is your voltage correct? Go up and see.
V1.
Yeah, it sounds right. This is cos sign, right?
Yeah. Value of what
Cos sign.
which is the or 20 plus
Should have sign that. Should have 120 minus 120. Yeah. Continue. So you do that, then you go with a uh, do that equation, not that I23
yeah.
minus I23 is equal to do that to get the current. You should ideally saying this as you have to say here V3 equal to V2, you beat that. Right. So now you can continue with the next. Can you check whether it's converging? You continue with that and then see whether it's converging. It's converging. You're not reached that far. Yes, I23 is Y03. Yes, good. You want to go to the next slide?
calculate conjugate. Because my answer is not coming like that.
For the last one, we move this.
So I put the conjugate calculate the conjugate. But after that, my answer is not there.
Is it SLO3 working?
That's it.
Oh. Can you not do multiplied by I? Is it working?
Not working.
Can you do V1?
Even
Let's try that. Not coming. See? So the problem is this multiply. Don't do multiply. Just I.
no, it's fine.
All are I. Just no multiply. It's not liking the multiply.
It's
All the way.
like a right.
Oh. So 2400, that is done.
Everything is coming.
Everything is good. Okay. Only your I load is not coming.
We said not that value, but coming,
Oh.
but not same.
No, that's okay. You continue.
Okay.
Continue. Yeah. Good
My
point.
I not
What is the number you're getting?
that value I'm getting.
That's fine. Continue.
Okay.
You got to multiply by 1000. Huh?
Okay.
It's multiply by 1000. Yeah. He said the same thing. I think the
But the answer is not same even if it will multiply by 5.
I understand. Yeah. But just for the last line, right? Yeah. Continue like that. See whether it converges.
No problem.
Got it. So very nice.
I did the division there. S load uh, 3 divided by V1 element wise division. I'm not getting that. It's a difference.
That's okay. I think you can continue. This is good. I don't think there is any, except for 0 1 to the power of E3, I note 3 as per to the power of E1. I note 3. I think this is good. The last one is not the one, right? Other two are okay.
Okay. I did a conjugate at the end. You wrote there, no?
Yeah. So my 54.42 minus 34 point, that is coming close. 53.12 minus. The next is minus 51 minus 23. Oh,
Somewhere wrong.
there is something wrong. 127, 80, 127, J80 is correct. Yes. The next one is,
This index is right now. S load 3
yeah, that is correct. That is correct.
element wise going.
Yeah, that's perfect. I don't think that's the problem there. Cos minus
One is cos minus 120.
cos I sine minus 120, that is correct. With 400 cos minus 240, I sine minus that is also perfect. And that is good. That's good. 127.5 I 8, 110 plus 75 I, 110 is 75 I, okay. 13 plus J10, 13 plus J10 E3. It looks like all are correct. I think you're good. Continue. I don't think, only thing is the next iteration, error should be slow. So I don't think, I cannot find anything. Maybe there is something which we are missing, but let's continue with that. So the next is, so this is done, right? So now you can say I23 is the same as this. After that, you can do this for node 2, next node, just this. Even doesn't match on the front, you continue with iteration. So node 2, how many of you have done node 2? Node 2 is done. Node 2 is done, so I have to do something here. So whoever is doing node 2, you can see this slide, node 2 is right here. And whoever is going to node 1, you can do the node 1 by this slide right here, the first calculating the next iteration for 1. By the way, if you use V1, you have to change that to V3. You got it, right? That's 1. So now what you do is you check the previous V1 with a calculated new V1, and then you will see an error. And then ideally, if you are a little savvy, you can put a for loop and then close it, or else you have to do step by step again. At least everybody should be able to go to V1. If you are done until V1, did you do until V1, node 1? Node 1, until node 1, and then you see error between the voltage in the previous 2400 and the new calculator voltage. I12 is not I-load. I12 is I23 plus I-load. I23 is the V3 divided by S load 3. Remember that? you calculated the I load 3, right? And then you add that with you understand, right? Yes, just so put that equation there, then you'll go to the next slide. It's time.
Next time, sir. So can we pause here and then we can
Continue on the next one.
resume in the next?
You cannot break that. Hunger is more important. Lunch is more important. Hunger, you cannot do anything without energy. Everything will be closed, right? I mean, also, you need energy to get. All right. So what? Yes.
Versus we actually
Hmm. That what is 46 point?
this is the maximum error.
Maximum. Okay. So what you do is that after you get 46, that maximum error, then what you do is you using the new voltage, repeat that, and then try to reduce that. So that maximum error is because you started saying all voltages are the same. Now all voltages obviously are not the same, right? So that error is your trigger or understanding that I need to adjust that voltage. So you use that error, I mean that voltage. So you had a voltage that you calculated with that error. That voltage you have to give that voltage with that error for the V3. Then you redo that back again. Okay, so there is a pause point suggested because of the time. The pause point is basically, we can continue, but the pause point is how many of you have completed one iteration, meaning how many of you have completed getting voltage 1 all that. Very nice. So that should be the place we should be now. So whoever has not reached that place, which is actually only 1 or 2 slides there away, you understand this, right? Let's see here, just to give an idea what we are. So let us see this right here. So let's recoup. Okay, let's recoup what you have done. You have a hands-on experience now, so you should really probably be able to understand. So 2 minutes I'll take, and then that's fine. So let's recoup what we have done. So what we have done is what just 2 seconds. I mean, you can continue. So what we have done is we looked at the electric grid, which has got 2 nodes in here, and then we got the impedances, and we said this voltage is known to you. So then the problem is to find these 2 voltages. That's a problem. So that voltages are not known to you. So what we did, we said this voltage is known to you. We assumed there is no load connected. So we said this voltage is same as this voltage is same as this voltage. We know that is not true, but we are starting from there. So we said V1 equal to V2 equal to V3. So then your V3 is known and your load is known. So load divided by V3 is a current that is flowing through the load. So we calculated that current. After we calculated the current, what you did was we used the impedance here, multiply with that current to find the drop and then see what will be the voltage in here. So we calculated that voltage, then you found this voltage back here. That voltage when we calculated, we realized, oh, that's not the one which we said. That we call it as an error. So that is one iteration. So what do you do after you get the error? Well, after you get the error, you say that this voltage needs to be adjusted based on that error, and you use that voltage, and then you come back and redo this in a loop again. So at least you did the first pass by hand. You should get a feel of how it's been done. So what do you do with the next pass and third pass? If you are, you can repeat it, which is good. But if you are smart, you will put that in what we call it as a loop. And that loop is generally called 2 type of loop. One loop you can do infinitely, and that is called while loop where you put a while condition or a condition saying that the error between these voltages that you calculated and then one should be less than or equal to whatever some number, and that's a while loop. Or you can repeat this process 200 times or 50 times and see what will so normally you don't go to while loop. While loops are considered infinite loops, which means you spin in the loop and then there is a bug in there, you keep spinning infinitely, you will not come out of the loop when that condition has been satisfied. So you put a for loop for 10 iteration or 7 iteration or something, see whether you reach this small point. So when we come back, you have two options, not two options, I think we'll see. But when we come back, we have two things to do. One thing is to talk about optimal power flow code. That will be little bit like a show and tell. I will show the code and then I will go through the code and how it's been running and I will show the results. So that's one job. And second job is you continue this in the loop and maybe I can give that optimal power flow code, you can train it yourself. So these are the two jobs that is pending, which we will cover in the afternoon, after the lunch.
Thank you, Professor, for valuable insights. We now break for our lunch. We request everyone to return at 2:45 for the next lecture and hands-on session.